Hello everyone, welcome back to CK24 channel. Today we will discuss some important points which help us in 2024 board exam. So let's get started. As you seen on the screen, the topic is construction, right? First, division of a line segment into a given ratio. Vijay's class teacher told him to mark 2 points A and B on a line segment PQ of length 10 centimeter such that PA by AQ equal to 3 by 2 and PB by BQ equal to 1 by 2. That means you know very well how it written. It may be written like this one, as you know very well. PA such that AQ equal to 3 by 4 or 3 is to 4. Don't worry about it. Okay. So he does not know how to construct. Can we help him? Now let's us try to make a point B in the same way. It is given that PB by BQ equal to 1 by 2. Let us take PB equal to x and BQ equal to 2x. In the ratio, we will take a variable with the given ratio, right? It is also given that PQ equal to 10 centimeter, but PQ equal to PB plus BQ. That means 10 centimeter equal to x plus 2x, 3x equal to 10 centimeter, and x equal to 10 by 3 centimeter. Now it is difficult to make a point B on the line segment PQ, since the value of x in decimal form and even non-terminating. We can observe that marking a point A was only possible due to two factors. We were able to measure the length of AQ and PA. The length of line PQ was divided by sum of the numerator and denominator in the ratio 3 is to 2. That is, the sum of numerator and denominator equal to 5. The length of PQ, that is 10 centimeter, was divided by 5. But in the second example, length PQ is not divisible by the sum of denominator and numerator of the given ratio. In order to carry out such construction, we follow two methods. Let us learn each of these methods with the help of examples. Let us suppose that we have to divide a line segment 8.8 centimeter into 4 is to 7 ratio. Let us discuss one more example to understand the concept better. Draw line segment of line segment length 6.2 centimeter and divide it into the ratio 5 is to 3. How can we solve? To divide a line segment of 6.2 in the ratio 5 is to 3, you follows the below given steps. Steps are very important while you are constructing any type of figure in mathematics. We draw line segment PQ of length 6.2 centimeter. Suppose take a scale and draw this one. Now we draw a ray PX making an acute angle with PQ and draw a ray QY parallel to PX by making angle PQY equal to QPX. Here is the main point. While you are drawing the line parallel to the respective sides, so the angles of PQ and QY are same. Acute angle means less than 90 degree. Approximately we are taking 45 degree, 60 degree, whatever you can take for drawing this type of line segments division. let's see on the screen. Here we locate 5 points P1, P2, P3, P4, P5 on Px. Where is the Px? Here is the Px. But how we can draw? Make a acute angle. First of all, you take an arc, then cut it, and you can go one by one. All the division of the line segment equal, and 3 points Q1, Q2, Q3 on Qy. Parallel to this one, you have drawn this one and draw this one, such that PP1, P1, P2, P2, P3, P3, P4, P4, P5, Q1, Q, Q1, Q2, Q2, Q3, all are equal. Means all acutes, you are cutting the line segment equally, right? Don't move your compass. Now we join P5 with Q3. The last of the line segment along PX, you join this point P5 from here to Q3, that is on QY, and which intersecting PQ at R. Here is the R, it is intersecting here, right? So next, now R is the point PQ which divide the line segment PQ in the 5:3 ratio. This point dividing the line 5:3 ratio. Very easy to draw. Okay. So no, I hope you have understand this one. Now next, construction of a triangle similar to given triangle. Consider the following triangles. First of all, you draw the rough as per given instruction, as per given values. Here ABC, right? AB is equal to side length 3.8 centimeter, BC equal to 7.9 centimeter, and AC equal to or CA equal to 6.5 centimeter, right? I hope it is very helpful to you. Now let's see. In the web figure, the measure of the sides AB, BC, CA are given like this one respectively. Can we construct a triangle similar to triangle ABC and whose side are 2 by 3 of the sides of the triangle ABC? Example you can see. Construct a triangle similar to following triangle with side 5 by 2 of the side of the given triangle. Right? So how can we draw? Firstly, my dear learners, we draw a QX, making an acute angle with QR. You see here. Triangle will be, sides are given. We make first QX, making an acute angle with QR and on the side of opposite to the vertex P. Here is the P, and mark 5 points corresponding to the greater of 2 or 5, x1, x2, x3, x4 and x5 on Qx such that Q x1, x1, x2 equal to x2, x3 equal to x3, x4, x4, x5. Means all the division are equal. There is no variation. If you vary it, it will be wrong. Now we join x to r. Now we join x to r. Corresponding to the denominator of the given ratio, and draw a line passing through x5 corresponding to the numerator of the given ratio and parallel to x to r. Let this line intersect the extended line QR at point R. Now we draw a line passing through R and parallel to RP, which intersects the extended line PQ at a point P. Let's see here. This one. You see here, this is a triangle QR. Now, and Q2, that is a Q2, here is a Q2, corresponding to the denominator of the given ratio, right? So, here Q2, here R. Now, let us see the figure here. Extended to the here, and Q2 is to R and X5 R1. And again you see we have extended QP up to P1, right? Like this one you can draw. Now next, construction of a tangent to a circle from a point outside the circle. We know that the tangent is perpendicular to the radius through the point of contact. Again I am repeating that we know that a tangent is a perpendicular to the radius through the point of contact. Therefore, we want to draw a tangent at a point of a circle. We have to simply draw a radius through at that point and draw a line perpendicular to that radius. It will be the required tangent at the point. However, we don't follow this method when a point lies outside the circle. This is because we do not know at which point on the circle the radius should be drawn, so that the line joining that point and point outside the circle is perpendicular to the radius. Example here, draw a pair of tangents to a circle of radius 4 cm from a point outside the circle such that the tangents are inclined at angle 70 degree. We can draw tangents using a properties of circle. It is given that the tangents are inclined at an angle of 70 degree. Therefore, the radii joining the points contact to the center of the circle are inclined at the angle of 110. You can see in the figure. You see here. Here is the outside point P. It is angle forming 70 degree. And the center at center, how many angles? Values 110. Firstly, let us draw a circle of radius 4 cm with the help of ruler and compass, right? Let O be the center of the circle, right? Then what can we do? We do here, let O be the point of center of the circle. Let's see. First of all, we draw the circle. We draw a radius OT of the circle. Now we draw another OQ making an angle of 110 with OT. Very good. Now we draw a line perpendicular to OT and OQ at a point T and Q respectively. Let us do perpendicular line intersecting at point P, this one, right? Thus PT and PQ are required tangents that are inclined at angle of 70 degree. I hope you have understand. You can see here, here is 110, here is a 90 degree, here is a 90 degree. When you add it, total will be 360 degree, right? So you see here 90 90 180 degree and plus 110 degree, right? How much it? 290 degree. When you subtract it from 360 degree, we get 70 degree, and we can use the protractor and measure it. Your construction is correct or wrong. Example 2, we can say draw a pair of tangents from point P to the given circle. Now let's see here. First of all, we draw the circle. In the given solution figure, the center of the circle is not given, right? Point is outside of the circle, right here. So therefore, first of all, we will find the center of the circle, right? So how? For this, let us draw two non-parallel chords of the circle and draw their perpendicular bisector. Here we have drawn opposite to this one, and the point of intersecting of this perpendicular bisector is the center O of the circle. You can see in the figure. You can more practice do. Now we join the line segment of OP and draw its perpendicular bisector. Let this perpendicular bisector intersect OP at M. Then we draw a circle with radius equal to OM. This one, OM. Taking M as a center, we draw the circle, right? M as a center. Let us circle intersect the given circle at point T and Q. We join PT and PQ, right? Here you see. The previous circle have to, on the circumference, this new circle have to intersect at T and Q. Now, Thus, PT and PQ are the required tangents from a point P outside the circle. Clear? So, for today, my dear learners, my dear viewers, thank you for watching this video and I hope you will do better. If any type of question asking from construction chapter in 2024 board exam, you can solve it. Have a nice day to all of you.